All right, here we go. So let's talk a little bit on parabolas. So you all have seen these before, but I'll just sort of expand on that a little bit. So parabolas. So there are two types of parabolas that we want to talk about here: horizontal and vertical. We'll start with vertical parabolas, the ones you are more familiar with. So vertical parabola, seen this before. And can identify the equation as y equals a x minus h squared plus k. There are several ways to write this. This is one way. One way that will be helpful for us. And we know, of course, that a parabola, all parabolas have what's called a vertex, and the vertex has coordinates h comma k. The vertex is the coordinates are h comma k, which we'll end up plugging in here. And of course we have this a value, and we know if a is bigger than 0, the parabola opens up. If a is less than 0, parabola opens down. Of course, parabolas also have what you all learned, Mr. Kurth, and we touched on briefly last semester, the axis of symmetry. Axis of symmetry, which splits the parabola into two symmetrical pieces. Two symmetrical pieces. And for vertical parabolas, we have an equation for the axis of symmetry. Notice it's a line, x equals h. So it's the equation of this line. Why is it x equals? Because it's a vertical line. X is constant, that is to say, the same value at any point. Questions on vertical parabolas? Okay, now we have horizontal parabolas, which will probably be a bit newer for you all. So let's jump in with horizontal parabolas. So horizontal, perhaps newer, I'm not sure if we saw these with Mr. Kurth or not. It looks something like this. So horizontal parabola here. And horizontal parabolas have the equation x equals a, y minus k squared h. Again, we have the vertex here. H comma k. And then we've got a, if a is above 0, to the right, less than 0. And again, the axis of symmetry here. Axis of symmetry splits into two symmetrical pieces. And the line is, this time it is a y equals line. It's a horizontal line. Y equals k. Questions? Cool. All right, let's keep going. Questions? Abraham, you still need the... You got it? Alright. Okay, so let's do some examples. So I'm on the homework now, folks. Let's do level 10, number 1. I think the number got cut off here. This is page 4. So 10.1. So on 10.1, they want us to write the equation of the parabola, identify the vertex, domain, and range. So let's make it happen. So when I look at this, I'm automatically seeing its horizontal parabola. Horizontal parabola with, equation for horizontal parabola, x equals a, y minus k squared plus h. When I look at this, I know right away that we have a vertex of this parabola at 0, -2. And when I look at this, I also see that this a value, a must be greater than 0, as we open right. So now we can start by plugging in the vertex into this equation. So plugging in the vertex into this equation. Clean it up a little bit. And this is what we've got so far. So now the only step left is we need to find a. And to do that, we're going to use a point on the parabola. So if you look at the parabola, there are infinite points on there, but you want to pick one that is obvious. So if I look at this parabola, there are several obvious points, in other words, ones where you don't have to round, but to me, this is the easiest one. So let's just plug in for x and plug in for y, and we can identify a. Let's verify you're agreeing with me on what a is. Once you've got a, you can then write your equation. And now we also need to find domain and range. We can do that by using our picture. I'll do that over here on the left. You can verify what you get with what I'm getting. And here's what I'm getting, so please verify. You agree? So let me stop here and take any questions before I do another problem. No questions? All right. Let's go. Brianna, go ahead. Oh, you just want me to hold up? Okay. The next one I'm doing, for those who are already done, just go to number 4 on page 5. Just begin doing number 4. Yep. So number 4, here we go. 10.4. So again, if you have questions, go ahead and ask. But I'm going to be doing this up here. I'd recommend you do it on your own. Verify once in a while with me. So here's what I've gotten so far. If you want to look up here, if you like to, if you don't want to, it's totally fine. Whenever you're done, you can verify up here. Let me know if we have any questions. Okay, no questions? Alright. So I'll go now to number 10 in section 11. Number 10 in section 11, so right below it. This is the one where they give us the vertex and the y-intercept, and they want us to get the equation. Alright, so step one for us here is just recognize that this y-intercept can be written actually in coordinate form. Remember, y-intercept means the point where x is 0, so the coordinates here are 0, negative 27 over 2. I might even rewrite this a little more as 0, comma, negative 13.5 to get it as a decimal. So I got the vertex, I got the y-intercept, let's graph it. Here's what we got so far. We know we have a parabola. We know it has a vertex at 5, negative 1, and it has to go through this point. So here are the potential parabolas we could have. So here's one option, a vertical parabola that opens up. We could have a vertical parabola that opens down. We could have a horizontal parabola that opens right. Or we could have a horizontal parabola that opens left. Of these four, and let me change one of the colors here. Of these four parabolas we have up here, only 2 of them are actually possible. Because only 2 of them satisfy the condition